Now let's look at the second proposition. To place at a given point a straight line equal to a given straight line. Right? So we have a given straight line. So let's say this is the given straight line. Now this straight line is on another line. So let's say this is the line on which this line is there, right? So you have AB and on which you have this BC, and this is at the end. At an extremity means at the end. So at the end of a line you have another line, and what we have to do is we have to create a line at this end which is equal to this line. Alright, so let's do it. Let's create an equilateral triangle. A little bit adjustment is required. Okay, now remember, we can use all the propositions which we have already learned. So we have learned in proposition 1 how to create a equilateral triangle on a given line. Now this time I am not actually going to draw the full circle because I don't really require it. What I require is an equilateral triangle, and for which I just create enough so that I get the intersection. Yes, to draw an equilateral, that's enough. So now yes, now what we are also going to do is we extend this line, right? And similarly we are going to extend this line. Okay, now that we have extended this line, so let us say this is ABC D, and let's say this is E and F. So now we have to mark this length on top of this AF. We can't just measure it here and cut it off here. So again, let's map this compass to this line and let's draw a circle. Okay, now we have a cutoff point, right? ABCDEF, let's say this is G. Now keeping the center as D and the radius as G, let's draw a circle. Every time we don't have to draw the full circle. It is enough to draw to that extent to which we require. Now we have a cutoff point here also. So let's say this is H. Yes. Now let's see how we can prove that BC is equal to AH. That is what we have to prove. Okay, now we know BC is equal to BG. Yes. Why? A radius of the same circle. Okay. So this is equal to this. We also know that DG is equal to DH. Why? Same. This is the bigger circle, this is the smaller circle. Okay. Now we already know that AD is equal to BD. Why? Because sides of a equilateral triangle. Now just look at this. This BH is equal to BG, right? But we already know that AD is equal to BD, right? So don't you think that means that the remaining part will also be equal? Remember, BG is nothing but the sum of these two parts. Similarly, DH is nothing but the sum of these two parts. Now, if one of the parts is equal, then the other part also has to be equal for the wholes to be equal. So therefore, AH is equal to BG. But we already know that BC is equal to BG. So BG. If two things are equal to the same thing, then they are equal to each other. AH is equal to BC, which is what we had to construct. So that completes proposition 2. To place at a given point at an extremity a straight line equal to a given straight line.